here is our third and last video for section 4.3 on polynomials. We're going to take a few minutes to do some application problems. So how can we use polynomials in kind of a real-world context? Well, if you look at example number 6 with me, it says here the number of watts of power, P, generated by a particular wind turbine at a wind speed of X miles per hour can be approximated by this polynomial. So they've come up with a polynomial to help us determine how many watts of power we'll get depending on how fast the wind is blowing, right? At this wind turbine, if wind blows at a certain mile per hour, remember that it looks like they called that X miles per hour, so X represents how fast the wind is blowing, we can kind of estimate how many watts of power, P, we're going to get out of this wind turbine. It says here to estimate the power generated by a 10 mile per hour wind. Now remember, X was the wind speed. And so when I say 10 miles per hour is my wind speed, can I really just say then that X equals 10 miles per hour? And so I should be able to use this polynomial, evaluate it by plugging in 10 everywhere I see an X. And that will help us figure out P, which is how many watts of power we'll get when the wind is at 10 miles per hour. So I'm going to take my polynomial, I'm going to evaluate it for X equals 10 by plugging in a 10 everywhere I see an X. And then I'm just going to make sure that I use the correct order of operations. Remember, we have to do exponents first before we multiply. So in my calculator, I'm going to do 10 cubed times 0.0157 plus my 10 squared times 0.1163. Now be careful. Some of your calculators can do it all at once. Some of your calculators, you might have to do it piece by piece and then add or subtract them together. Just be careful. But what I suggest you do is pause the video, take out your calculator now, put this in your calculator, and make sure you get the same answer as I do before you continue. So making sure you follow the correct order of operations, in my calculator, I got a final answer of 17.6403. There was a whole bunch of numbers after that, ... So depending on how they want you to round it, I can say on this one that if I'm rounding to the nearest tenth, I can say 17.6. Now, if this were a word problem, I would really like you to explain to me what our answer means in words. So great, we got 17.6, but who cares if it doesn't really mean anything, right? So let's put some words to this answer. So what does the 17.6 mean in context to this problem? Well, the 17.6 was our P, and what did the P represent in this scenario? Wasn't it really the power that we were going to get out? If the wind was blowing at 10 miles per hour, we were going to get a certain number of watts of power. And so this 17.6 is really 17.6 watts of power when the wind blows at 10 miles per hour. So making sure you can put a label on your answer is really important on these word problems. So that way you know how to get an answer, but you actually know what that answer means. Okay? All right, in example number 7, we're going to use the same polynomial from the last example about the watts of power, but instead of looking at the polynomial as an equation, what they've done on this example is they've graphed it for us. So this is the same exact equation that we use for our 10 mile per hour wind and the wattage of power that we're going to get out, but as a graph. And it asks us to use the graph to estimate the power generated by a 30 mile per hour wind. Now we can find out what it is back in our polynomial by plugging in a 30 just like we did a 10, but we don't want to do that on this one. We just want to use the graph this time to kind of estimate. So you can see here on the graph at 25 miles per hour, the power wattage is 288.2 watts. At 35 miles per hour, if you have a 35 mile per hour wind, you're going to get 772.4 watts, but estimate using the graph what it would be at 30 miles per hour. Well, if my x-axis represents my wind speed, miles per hour, and I'm looking for 30, I should be able to follow it up to my graph and figure out approximately how much power I'm going to get if my wind is 30 miles per hour. The power over here corresponds, it looks like, between 400 and 600, so I'm going to estimate that the wattage of power that I'm going to get when x equals 30 miles per hour, the wind is 30 miles per hour, is approximately 500 watts of power. Now it's not exact, but we're not trying to do exact, we're just trying to estimate using the graph. So you should have said somewhere around 500 watts of power by using the graph. All right, now that we are done with all of those different examples for polynomials, I would like you to try a few problems for me. So I'd like you to pause the video. I'd like you to try these 4 for me to practice the concepts that we just talked about in this section before moving on to your homework and before going on to the next section. All right, in try it number 1, it asks us to classify. It looks like here we have 2 terms and we have a 3rd degree. So I would classify this as a cubic binomial. It's to the 3rd degree. It has 2 terms. We call it a cubic binomial. All right, identify the leading coefficient and the degree. Now be careful. This one's kind of tricky because it says leading coefficient. It doesn't just ask for the coefficient of each term. It asks for the leading coefficient. And remember, in order to identify what the leading coefficient is, we have to make sure that we put our polynomial in standard form. So I'm going to do that first, writing it from highest exponent to lowest. And now I can say that my leading coefficient is the number in the very front, which is 9, and my degree is 2. This is a quadratic trinomial. All right, number 3 asks us to take this polynomial and combine like terms. Remember, they have to have the same variable and the same exponent in order to be able to be considered like terms. So it looks like here I have a 9b to the 5th minus 2b to the 5th. That's 7b to the 5th. I have a 3b squared and a negative 3b squared. 3 minus 3 is 0, so they just end up canceling each other out, zeroing each other out. And so normally we wouldn't put plus 0b squared at the back. We just wouldn't put anything. So actually 7b to the 5th power would be our final answer here after combining our like terms. In number 4, it asks us to evaluate this trinomial when x equals negative 3. So wherever you see an x, you should be plugging in a negative 3. Making sure that you follow the correct order of operations, you should be doing your exponents first before multiplying. So negative 3 squared, that's negative 3 times negative 3 is positive 9. Then you can go through and start to multiply before you add or subtract. I ended up getting 18 plus 9 plus 7, or a final answer of 34. Hopefully you got all of those try-its right before moving on to your homework in the next section. Let me know if you guys need anything before we keep going.